Hey everybody, this is Larry. This is me going over day 19 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think. Got a haircut, I don't know, just feel like people are vlogging or something, right? Anyway, sequential digits, let's get to it. An integer is a sequential digits if each number is one more than the previous digit. Okay. So I think for this one, what I would recommend is just generate the entire list and then go through the entire list to see whether the low or high, within the low or high. The reason why I can say that is that if each, so I did a lot of back of the envelope or back of my head calculations. Maybe it's a little bit hand wavy right now, but for example, if you are looking at 3 digits, well, and this isn't even correct, but you can say that there are most 9 or 10 numbers within 3 digits, right? Because it can only start with 1 or 2 or 3 or 4, and actually obviously it's actually less than that because 7, 8, 9 is the biggest number because you can't do 8, 9, and 10 obviously because then there'll be more. So roughly speaking, for each digit there'll be about 10 numbers, and for and you look at the constraints, and I was just thinking about ints in general, but it can have most half. It can at most have 10 digits or something like that, right? So that means that there are 10 numbers, 10 digits. That's only 100 numbers, so you could do a linear scan. You can maybe even binary search if you really want to be fancy, but for 100 numbers, I would be too lazy to do it. But that's how I'm going to start doing it. Yeah, and there are a couple of ways you can probably start doing to do the actual construction itself. I think I'm just going to do a breadth first search type thing where I start with 1 digit and start from 1 to 9 and then just keep on building to it. So yeah, okay. Basically, I'm just going to put everything in a set. Yeah, I hate using single variable names for a set. For anything, but my numbers are all numbers maybe. I don't know. That's better. Naming things are hard, but yeah. So then maybe I would do something like current is equal to a list of let's see, right? X for X in range of 1 from 1 to 9 inclusive, so that's 10. And then that's pretty much, then we just get started. So then now I just do it for each digit. You could do some math to kind of bound it, but I'm not going to right now. So let's just loop this 11 times, say, because basically you probably do 10 times, but I'm always like, for stuff like this where if you're just doing 10 extra operations, I don't want to count off by ones and stuff like that, right? So I'm just doing 11. In theory, you could even do 12 in a body, okay, because you don't overflow in this one. But yeah, so all numbers for number in current, all numbers dot append or dot add, I guess, because it's a set number, and then now for each number in it, we want to add a new digit to it, right? If possible. So we go for number in, okay, let's just do also, oops, next candidates. Let's go to new array. Let's call these current candidates. So we can do that. We add the current number, and then the next candidate is just equal to the number. Let's say mod 10, right? Well, okay. Let me break that down a little bit better. I was going to do a one-liner, but last digit is equal to number mod 10. If last digit plus 1 is less than or equal to 9, and you could maybe do it the other way, then next candidate dot append number times 10 plus last digit plus 1, right? And to show how to see for yourself why this works, and basically we just take the last digit. If we take the last digit and we add 1 to it, which is, literally what the prompt statement is asking for. It's less than 9, then we just do this thing where we shift it by 1 by 10, or multiply by 10 and then add that last digit plus 1, since we know that this will be from 1 to 9 or whatever it is, maybe not even 1 per se. Yeah. And then at the very end, we set current candidates is equal to next candidates. And then at the very end, we can just do a simple count from between low and high, right? So then now we do return, and maybe I would show off a one-liner. Or maybe, is it count? Let's just do len of x for x in all numbers if x is between low and high. And have to double check that it's inclusive. Okay, it is inclusive. So that should be pretty much all the things that I need to test. Oops. Oh, some of these are strings, so I may have to, maybe? I don't know. I have to take a look at the error message. And also just test 1 and 10 to the 9. So, oh, it starts at 10. So 10, so it's 3, 4, 1, 2, 3, 1, 2, 3, right? Okay. So I have to return a list of integers. Oh, for some reason, I thought I had to return to count. So that's my, actually even easier, well, straightforward to what we had to do. Do we have to sort it? I guess it doesn't say, but it should be okay. We don't have to in the right order. I don't know if I need to sort it, so I'm just going to sort it just in case, because and most, like I said, it's going to be 100 numbers, so I'm not going to worry too much about the performance of the sort, though it just depends on the statement. And of course, you can also add things in a way such that, because this doesn't actually have to be a set, right? Because we know that we're not going to repeat numbers, so this could just be a list, so you don't have to sort that way. Okay, fine. Do it that way then. Yeah, so that looks good. Let's give it a nice submit. And yay. So again, to go over the complexity, because, well, we know that at most going to be 10 digits. So let's say it's all of 10 or all of 1. And then we just go through all the candidates. And again, for each digit, there are at most 10 candidates. So this does at most 10 operations, it goes through 10 iterations of the for loop. These are all 1 operations. So yeah, it depends on how you want to count the digit shifting and stuff. But for me, I'm going to count it as all 1. So that means that this is about all of 10 times 10, or maybe another notation, but all of the number of digits times 10. So all of d. So yeah. So and then we just go for this, and again, this is about all of the number of digits times 10 per digit or something like that, right? And technically beyond 10 it wouldn't even get higher. So depending on how you want to talk about it. But yeah, that's what I have for this problem. So definitely think about using this technique. I think the queer, I think, it's probably natural to go do a for loop from low to high, but when you see these constraints, it's very obvious that that's going to be too slow, because a billion is too slow. You want to keep something in at most like a million-ish, maybe 10 million-ish range, depending on what you're doing and how much work you're doing. But yeah, cool. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord, and I will see y'all tomorrow. Bye-bye.